Yes. Alright, so last time we looked at extraction of zinc. So today this is lesson 2. Okay. Lesson 2, extraction of iron under extraction of metals. Therefore, in order to extract the iron, what you need to understand, number one, is the method of what? Extraction. Secondly, the charge. You need to also know what consists, what made up what makes the charge. Okay, and then the other thing that you need to know is the role of each material in the blast furnace. Firstly, extraction of iron. Iron is extracted by reduction method. Okay, by reduction what? Method. Okay, this is the method by which iron is extracted. Now, why this method? Because iron is fairly what? Fairly reactive. Okay, it's not more reactive than the other metals like aluminium. We also have calcium, magnesium, and the sodium. Those are reactive metals. So to extract reactive metals, you need to use what? Electricity. Except the method known as what? Electrolysis. Okay. Now, they are basically 3 ores of what? Of iron. Remember, an ore, alright? An ore is a compound of impurities from which a metal is extracted. So the first ore is called hematite. Alright? Hematite. Hematite, its chemical formula is, this is iron 3 oxide. This is iron 3 oxide, hematite. Alright? This is iron 3 oxide. And then you also have what? Magnetite, right? Okay? Magnetite. Magnetite, this one is tri-iron tetra oxide, right? Huh?
Yes, sir.
Okay. Which is this. Okay. And then you have a 4 there. Alright, this is the chemical formula. Then you also have what? Siderite, right?
Yes.
Alright. Now in this lesson we're going to use hematite. Why are you using hematite other than magnitude and the siderite? It's because that in the hematite ore there is 60% of iron. Alright. 60% in the hematite there is 60% of what? Composition of iron. So 40% is just impurities. Okay? Like this magnetite and siderite. So even magnetite is slightly is closer to 60%, but you usually use magnetite. Hematite, sorry. Hematite. So now, extraction of iron is extracted in the furnace called what? Blast what? Furnace. And the blast furnace is just a tower, a metal tower of about 30 to 40 meters tall, right?
Yes.
30 to 40 meters tall. And this one is made of what? Steel blocks, huh?
Yes.
That they have high resistance to heat. Meaning they have high melting point. Okay? Indeed, this has to have what? High melting point because there is heat inside here. Alright, heat inside of about 400 degrees Celsius. About 400 degrees Celsius going up there. 400 degrees Celsius. Now, let's talk about the charge. The charge is a mixture of 3 things. Iron ore, usually hematite, in this case hematite, coke, which is carbon, limestone, which is the calcium carbonate. So, these are fed into the furnace at the same time. Okay, using this point here. So they are fed into the furnace here, and the reactions that occur here, we have number 1. let's start with coke, and then we go to limestone, then iron ore lastly. Okay. So let's start with coke. So when you look at the coke here, coke is carbon, right? Coke is carbon in its solid what? Yes, in its solid state. Now, this coke reacts with what? Oxygen in air. When you just put this inside here, eventually coke starts reacting with oxygen.
Yes.
Alright? So it reacts with oxygen to form carbon dioxide. So this is solid, this is gas, and this is also what? A gas. Alright? This is carbon dioxide. This is the first reaction. Coke reacts with air to form what? Carbon dioxide. Okay. It's already balanced, right?
Yes.
Yes. Alright. Second stage. So that's it. The purpose of coke here, the first place is to come up with carbon dioxide. Right?
Yes.
Yes. We'll reuse this coke later on. Let's go to limestone. Alright. Limestone. Limestone is calcium what? Calcium carbonate. Now, this calcium carbonate doesn't react with anything, but it just thermally decomposes. Okay? It decomposes using heat. So we have heat here. This one, it decomposes into two products, namely, what? Calcium what? Calcium oxide, which is CaO, and carbon dioxide. What is common in the two reactions?
Carbon dioxide.
Carbon dioxide is produced, right?
Yes.
Good. So this is solid, and this is what? Gas. Yeah, that's the matter of balancing. In fact, it's already balanced. Yeah, it's balanced. So the carbon dioxide that is produced here in the first reaction and in the second reaction, all right, they circulate, right? They circulate and they react with coke. They further react with coke, all right? So let's call this one as the third reaction. So coke reacts with carbon dioxide to form carbon monoxide. Alright? Alright. Carbon monoxide. This is solid, this is gas, and this is also what? Gas. That's the matter of balancing, right?
Yes.
Carbon 1. I mean carbon 2, right?
Yes.
Carbon 2 on the right hand side, then you have carbon 1. So put the 2 here, carbon balance that. Oxygen on the right hand side we have 2. Then because of this coefficient, oxygen also is what? Balanced, right?
Yes, sir.
Okay. Now, what is produced is what?
Carbon monoxide.
Carbon dioxide. Mono. Not di. Carbon monoxide is produced. Now, we can now use hematite is HAE. It's like hemoglobin. It's HAE. Right?
Yes, sir.
Now, hematite is